All right, so today we're looking at section 2 of chapter 8, which is multiplying and dividing rational expressions. So this is going to bring you back to, how did you multiply fractions back in 5th and 6th grade or 4th grade, whenever it was that you learned this? And how did you divide fractions? So it's going to follow the same rules. We're just going to bump it up a notch because we're going to be looking at polynomials with that. So we're going to follow those polynomial things that we've been doing and then reduce and all that good stuff. So remember, when multiplying fractions, you just do top times top and bottom times bottom. But remember, it's always easiest to look for things that will reduce before you multiply. That way you don't have to do it later because it makes it a lot tougher. So these first four examples are very simple. I'm looking at number 1. And remember, you're looking for something on top and something on bottom that can reduce. I don't see anything on this one, so this one's nice and easy. We're just going to do top times top. 25x times 1 is still going to be 25x. On bottom, 2 times y cubed is still 2y cubed. And because we already checked to see if it would simplify before we multiplied, we know that our final answer isn't going to reduce either. Number 2, however, we have quite a few things that are going to reduce. I'm looking at the coefficients, and I see on top I've got a 7 and on bottom a 14. So both of those are divisible by 7. This is really negative 7. So negative 7 divided by 7 is going to give me negative 1 there. And 14 divided by 7 is going to be 2. Other coefficients aren't going to reduce. 5 and 3 or 3 and 2 don't reduce. Then I'm going to go ahead and start looking at letters. I see the x's first. I've got x squared on top and x squared on bottom. Those are the exact same, so those are going to cancel each other out. With my y's, remember our rules about exponents. We want to get rid of the one that's smaller. Which is smaller, an exponent of 5 or an exponent of an understood 1? Well, 1 is smaller, so we're going to get rid of it. And if we get rid of 1 here, we have to take 1 away from that one. So that's going to leave me with y to the 4th there. So this is a little bit messy, so you just got to be, paying attention to what's left and don't forget anything. So I've got negative 1 times 3 y to the 4th. If you multiply that out, that's going to be negative 3 y to the 4th. On bottom, it looks like I just have a 5 and a 2 left. 5 times 2 is 10. And again, I know this answer is my final answer because I did all of the reducing I could before I multiplied. 3 and 4 are going to follow the same thing. On 3, nothing reduces, so we just go ahead and multiply straight across. 4a times 3 is 12a. On bottom, b to the understood first times b to the second. Remember, you add your exponents when multiplying. That's going to be b to the third on the denominator. On number 4, just much like number 2, I notice the coefficients, 3 and 9, are both divisible by 3. So negative 3 divided by 3 is negative 1. 9 divided by 3 is 3. No other numbers are going to divide. And then next, the letters. I have q squared on bottom, q to the third on top. 2 is smaller than 1, so I'm going to subtract 2 from both of those. That's going to leave me with q to the first, but I don't really need the first. Make sure that looks like a q and not a 9 so you don't confuse yourself. And then my p's match exactly, so those are just going to cancel each other out. And then just be careful. So I've got negative 1 times 2q. That's going to be negative 2q. On bottom, I just have the 3, so I rewrite it. So those are pretty easy examples. We're going to bump it up a little bit down here at the bottom. We're going to have more polynomial type things. So the steps are to factor any polynomials that will factor, and then we're going to reduce things as much as possible and then multiply what's left out. And we're going to really just keep it, if there are parentheses next to parentheses, we're not going to FOIL that out. We're just going to keep it as it is. So I'm looking at this numerator, and I see that there is a GCF there, so that one's going to factor. It's divisible by x. If you were to divide both of those by x, you would be left with x plus 1. And then this denominator is the other polynomial that's going to reduce or factor. It's going to divide by 5, which is going to leave you with x plus 1. So obviously here, we've got an x plus 1 on top and an x plus 1 on bottom. Those are going to cancel each other out. Another thing I notice is there's an x here and an x there, those are multiplying, so I can cancel those out also. X is gone and x is gone. And then another thing that I see is that there is a 3 on top and a 6 on bottom. So those are both divisible by 3. So that one's gone. 3 divided by 3 is 1. I don't really need the 1. 6 divided by 3 is 2. So again, be really careful showing all your work and making sure you're accounting for everything. Looks like everything is crossed out on the top except for that 2. So I'm going to have a 2 in the numerator. And everything is crossed out on the bottom except for that 5. And those definitely don't reduce. So it looks like that all simplifies just to 2/5, which is really pretty interesting to think about. Because look at what we started with. Who would have guessed that that just simplifies to 2/5? Number 6 is very similar as well. Again, I noticed two things. This one is going to be able to be factored, and that one you should hopefully recognize that's a difference of squares. So that factors very easily to the square root of each term, 1 plus and 1 minus. The square root of x squared is x, the square root of 1 is 1, 1 plus and 1 minus. So those cancel. And then looking at the numerator of 6, I'm going to have an x for a GCF, which leaves me with x minus 1. Okay, so now I've got everything factored. I'm going to go ahead and start looking for things that cancel. I have an x minus 1 on top and bottom. Those will cancel each other out. I cannot cancel this x with that x because this one is a cross addition. However, I can cancel this x with that x because those are being multiplied. So those are fine to cancel. And then similarly, I've got a 5 and a 15, both divisible by 5. 5 divided by 5 is 1, so that one's completely gone. 15 divided by 5 is 3. I think I've canceled everything that I can, and I just look what's left. Everything's crossed out except for the 3 in the numerator, and everything's crossed out except for the x plus 1 in the denominator. So that's going to be the final reduced answer. And remember, you can't do anything with reducing a cross addition, so the 3 and the 1 are just going to kind of stay like that. Okay, and we'll see some more examples on the back. Again, a little bit more difficult here, but not too bad. You've seen worse things. This trinomial is definitely going to be the hardest one to factor, so I'll probably start with that one. I see that it's got that 2 out front, so I got to make the magic number. So the magic number is 6. I'm looking at the ones that subtract to make the understood positive one. That, of course, is going to be 2 times 3. So I have to make it a positive 1x, so that would be a 3x minus 2x. That's still the same as positive 1x. The other two things I'll rewrite, 2x squared and minus 3. Okay, so we did that. We made that 4-term polynomial to factor it by grouping. So we'll group the first two and the second two. In the first group, looks like there's an x in common. If you were to divide by x, that's going to be 2x plus 3. In the second group, remember you don't want your first term to be negative, so we're going to factor out a negative. There's nothing else really in common. This is the only time I do put in the understood 1, just so I don't forget about it whenever I put it in the other parenthesis. And if you were to divide both of those by negative 1, again, it's 2x plus 3. Those parentheses match, so you know that you've done it correct. And it factors to its final form of 2x plus 3 times x minus 1. So all of that, I'm just going to scratch it all out now. And I've got my final factored form on top there. Okay. The other ones are not as hard. They're going to factor a little bit quicker. This one, there's just a GCF of 3. So it's going to be 3 times x plus 1. If you divide that by 3, that's what you get. The next one, I don't like the order that this is in. So the first thing I'm going to do, because we want it from highest exponent to lowest exponent, I'm going to rewrite it as the negative 5x squared plus 5x. My lights keep turning off, so that's fun. It's actually like 7:30 at night when I'm recording this. Isn't that great? But anywho, look at that. And you don't want your first term to be negative, so we're going to factor out the negative. There's a 5x in common. If you're to divide by negative 5x, that's going to leave you with x minus 1. So I'm going to cross all that out. This one, it's a binomial. There's no GCF, but I do notice that difference of squares pattern. So the square root of 4x squared is 2x. The square root of 9 is 3. So it's going to be 2x plus 3 and 2x minus 3. Okay, I got a lot written there. So we just got to make sure we account for everything that matches. I see on top and bottom the 2x plus 3 are right above each other and below each other, so those are gone. And x minus 1 on top and bottom, those are gone. X plus 1 doesn't match. That doesn't match. The 3 and the 5 are not divisible, so it looks like we're all factored out and simplified as much as we can, so we see what's left. I've got the 3 times x plus 1 on top. On bottom, I've got a negative 5x and a 2x minus 3. Now the only thing I don't like about this final answer is that negative in the bottom. I don't like that. So I'm really going to take this just one small step further. I'm going to float that negative out to the front, or better yet, probably all the way to the top. I like the negative in the top best on these. So I'm going to make it negative 3 times x plus 1 over 5x times 2x minus 3 for a final answer there. All right, I got the lights back on, and we're on to number 8. So it's much like number 7. I'm going to start with the toughest one just to get it out of the way. Magic number again, because there's no GCF. 3 times 5 is 15. I'm looking at the factors of 15 that subtract to make 2. That's, of course, 3 times 5. I need it to be a negative 2x. So that's going to be 3x minus 5x. That is negative 2x. The other things get rewritten. 3x squared plus and minus 5. Okay, we did that to group them together. So let's make those groups. Looking at that first group, looks like there's a 3x in common. If you were to divide by 3x, that's going to leave you with x plus 1. In the second group, there's a negative 5 in common, which is going to leave you with x plus 1. Those match, so that's great. So we have the x plus 1 that matches, and then the leftovers, 3x minus 5. All right, so again, I'm going to cross all that out so it doesn't confuse me when I go to cancel things here in just a little bit. This one, much like the previous one, is not quite in the right order, so I'm going to think of it as negative 3x plus 6. And then we're going to factor out that negative 3 that's in common. So negative 3 divided by negative 3, that's going to leave you with x minus 2. All right, I'm done with the numerators. Let's look at the denominators. That one's in the wrong order also. It's going to be 6x squared plus 6x when it's in the right order. And of course, that means there's a 6x in common. Divide by 6x, and you got x plus 1. Cross all that out. And then this one, you'll notice again a difference of squares. So the square root of x squared is x. The square root of 4 is 2. So it's going to be x plus 2 times x minus 2. All right, so I've done all that. Now I just look for things that match on top and bottom, and I cross them out. The first thing I notice is the x plus 1s. They match. I also see the x minus 2s. They match. Those don't match. Now this one, I've got a 3 and a 6. Those are divisible each by 3. So negative 3 divided by 3 is negative 1. 6 divided by 3 is 2. I'm going to go ahead and rewrite that x so that I don't forget it. And then just be really careful and put all of these things together. So I have the negative 1 and the 3x minus 5 on top. So negative 1, I don't really need the 1, so I'm just going to turn that into a parenthesis. Negative times 3x minus 5. On bottom, I've got the 2x. My lights just turned out again. Times x plus 2. And again, I've already done the simplifying, so nothing else is going to reduce. If you wanted to distribute that negative, that would be okay. But I'm just going to leave it like that. I like that for an answer. Okay. Last section is division of polynomials. Just remember the rules when dividing fractions. You flip the second and you multiply. So really you never divide whenever you're talking about fractions. So the first thing I'm going to do is I'm going to rewrite this whole thing with that one flipped. So I'm going to rewrite it as 6x plus 2 over x squared minus 1 times, just flip that one, x minus 1 over 3x squared plus x. All right, from there, we're going to go ahead and factor. These are all pretty easy ones. The first numerator is divisible by 2. That gives me 3x plus 1. That one's fine. This denominator is a difference of squares, factors to x plus 1 times x minus 1. This denominator is divisible by x, which would give you 3x plus 1. All right, so I've got everything factored. Now I'm just going to cross things out that match. I see the 3x plus 1's match. I see the x minus 1's. And that's going to be it. So it looks like my final answer is going to be the 2 that's left on top. The x I'm going to put out front of the x plus 1 because that looks better. And there you go. Again, you do not need to multiply those together. You've got that's just more work than what you really need to do. Number 2 is pretty similar. Again, it's a division problem, so the first thing I'm going to do is rewrite it as a multiplication problem. So it's going to be 10x minus 2 over x squared minus 9 times x plus 3 over 5x squared minus x. And then I'm going to factor everything that I can. Starting with that first numerator, those are divisible by 2. If you were to divide by 2, that's going to be 5x minus 1. That one doesn't factor. This one's a difference of squares. It's going to be x plus 3 times x minus 3. This one has a GCF of x. Going to leave you with 5x minus 1. Now that everything's factored, we're going to go ahead and find the matching things on top and bottom and cross them out. 5x minus 1's, x plus 3's, and then just like the last one, looks pretty similar. I've got the 2 left on top. I'm going to put the x out front of the x minus 3. Leave it like that. Just 2 more examples here, and then you can get started on your assignment. Looks like we've got one of those nasty ones. We got to make the magic number, so that's going to take a little bit more work, but not too bad. So I'll go ahead and rewrite it, and I'm going to leave a little space because I'm going to go above it. I think that works out a little better. So 2x squared minus 11x plus 5 over 5x minus 25 times, go ahead and flip that one, 10 over 4x minus 2. See if I can get these lights on. Yeah? No? Okay, we'll just go without the lights. It's not too dim. Okay, magic number 2 times 5 is 10. The factors of 10 that add to 11. Of course, 1 times 10. But it is a negative 11x, so we're going to rewrite it as negative 1x minus 10x. The other 2 things get rewritten, plus 5 and the 2x squared. We did that to group them together. So group these 2 and those 2. What's in common in that first group? An x. If you divide by x, that leaves you with 2x minus 1. Don't want our first term to be negative. They're also divisible by 5, leaving you with 2x minus 1. Those parentheses match, so that's good. And we'll have the 2x minus 1 that matches with the x minus 5 left over. All right, all of that is no longer needed, so we're left with those. On bottom, these are nice and easy to factor. This one's just divisible by 5, leaving us with x minus 5. This one's just divisible by 2, leaving us with 2x minus 1. All right, so now that we've done that, we'll just look for things on top and bottom that match. 2x minus 1's match, x minus 5's match, and then I'm going to do a little bit of multiplication here because I see 5 times 2 is 10. So I've got 10 over 10. All of this, sadly, all of that work just to get 1. Isn't that great? Wow. Do you think number 4 will be the same? I don't know. We'll have to do it. We'll do it real quick, though. I'll go quick on this one. So follow along. Here we go. First, let's rewrite. 3x squared minus 11x minus 4 over 2x minus 8 times 6 over 9x plus 3. All right, the magic number here is 12. I'm looking for the factors of 12 that subtract to 11. Again, it's going to be that 1 times 12. So it's got to be a negative 12x and a positive 1x. That's still negative 11x. Rewrite the other things. We did that to group them together, so let's make the groups. What's in common in that first group? A 3x. Divide by 3x, and you're left with x minus 4. In the second group, there's nothing in common, so that's the understood plus 1 times x minus 4. Those match, so that's good. X minus 4 times the leftovers, 3x plus 1. Okay, I'm going to cross all that out so I don't get confused by it. This denominator is divisible by 2, leaving us with x minus 4. This denominator is divisible by 3, leaving us with 3x plus 1. Okay, now we'll just cross things out that match. I see the x minus 4s. I see the 3x's plus 1s. And once again, 2 times 3 is 6. 6 divided by 6. This one came out to be 1 also. Isn't that great? All that work for an answer of 1. So good luck. This isn't much new. You should do just fine. Just keep those rules of factoring in mind. Good luck.